Now that blockchain scaling is essentially solved, we can finally onboard the world to crypto. But people have reputations, credit scores, and financial history in the Web 2 TradFi world, and if coming to Web 3 means leaving all that behind, then adoption will be limited. Fortunately, though, there's a way to use zero-knowledge proofs to import this ocean of data into Web 3. In this video, I will explain why zkTLS could be the key to crypto mass adoption. Note, this video was made in collaboration with EigenLayer, but as always, all views expressed are my own. The modern world that we live in runs on this complex overlapping mesh of centralized services. These systems, these networks, which manage different aspects of our lives. And each of us has histories and reputations in dozens of these systems. For example, we have financial institutions tracking our credit scores, financial history, debt and assets. We have social media systems tracking our content creation and consumption over the years. We have marketplaces like Airbnb and Uber, tracking our reputation and participation in those marketplaces, Spotify tracking our musical preferences, etc., etc. And so we have this whole constellation of these systems tracking different facets of who we are in the real world. And some of this data is really consequential. Your credit score, for example, in combination with your employment history, etc., that information may determine whether you get a mortgage or not, or your access to credit more generally. So that's pretty important, right? Your rating as an Uber driver might determine whether you can earn a living. Your reputation in Airbnb as a host might determine whether you have a secondary income from a rental property. And even your social media footprint over the years captures something very intimate about who you are and how you've changed. And as personalized AI becomes more viable, this information becomes pretty important. So these systems are managing much of the modern world, much of our personal reality. Now, with Ethereum, we have the introduction of this new platform, this world computer. And this platform can be host to the next generation of these systems. We can rebuild, in a sense, the modern digital infrastructure that runs our world on Ethereum and make it better and more transparent, et cetera, et cetera. But one of the things with Ethereum is that it's a closed system. In order for it to be secure and to work properly, Ethereum can't just read out into the outside world. It's self-contained. It can't see the outside world. It can't see all of this stuff that we've built up to manage our society. So the way that's generally addressed is with oracles, right? So when we're talking about the price of gold or the price of a stock or something, this is stuff happening out here in the wider world. Ethereum can't see it by default. So we use oracles. We use these systems to bring that information from the outside world into Ethereum in a secure way. But oracles generally work for public data, right? Stock prices, commodity prices, these are public points of data. And oracles do a good job of bringing that into Ethereum. But most of what I'm describing here is not public, right? Your credit score is not public. Your bank balance is certainly not public. And even your rating as an Uber driver is not necessarily public, and social media histories, all these things. So, but as I've said, this information is really actually pretty important to your life. And so if we're going to rebuild our global infrastructure on the platform of Ethereum, it would be helpful to import that data into Ethereum as well. And to do that, we have zkTLS. So the way zkTLS works at a high level is that it allows us to prove some specific information has come from some specific official source, one of these servers in these centralized systems. So for example, we might prove that our bank is reporting our checkings account balance at some specific amount. Or we might prove our credit rating is some number. Or maybe we prove that our rating as an Uber driver is 4.9 stars. Or we prove that we've been an Airbnb host since some date, anything like that. And one way to think about this is it's sort of like, very roughly, it's sort of like taking a screenshot. You know, if there's some profile page or accounts page in one of these services that you could take a screenshot of and maybe show to somebody, it's kind of like doing that. With zkTLS, we can capture some of this information that these services expose to you as a user, we can take like a capture of that and bring that into Ethereum and then do something with that information. Now, the important difference between zkTLS and a screenshot is obviously screenshot can be photoshopped, etc. With zkTLS, it's a proof, right? You're generating a proof of some information. The other thing is, this is similar actually to a screenshot, but this is an important point, is that with zkTLS, the grabbing that information and generating a proof about it is something that these servers don't need to actually allow us to do. They don't need to change anything. They don't need to add an API endpoint. They don't need to do anything. We can just, if they're giving that information to us as users, we can generate a proof and grab that information, bring it into Ethereum. So it's unstoppable in that sense, right? Unstoppable, provable information. And the other thing is it's also selective. So selective disclosure of information. So unlike a screenshot, you don't have to expose all of your bank details to some DeFi app if you're going to generate a proof for that app. You might only want to prove to that DeFi app that you have at least, $20,000 in your savings account, or you hold at least $10,000 worth of some stock. You don't have to expose all of your details to that app. You can selectively disclose things and prove things about the information, right? And the other thing is it's not just like, unlike a screenshot where you're just grabbing static data, with zkTLS you can prove things about static data, but you can also prove actions. So you can prove that you've taken some action in one of these centralized systems. So you might prove that you bought some specific stock on some specific date, and you bring that to the DeFi app, and then it does take some action based on that. So that's kind of a high level picture of what zkTLS does. Now it's important to understand what zkTLS is really proving and what its limitations are. As I mentioned earlier, zkTLS will just prove that some specific information is being reported by some specific official source, some server for one of these systems. But zkTLS can't somehow discern what the actual ground truth of the universe is. If one of these services is misreporting some information, zkTLS can't detect that fact. So, for example, suppose you have a bank account and you have $100,000 in the bank, and then one day the bank is reporting your balance as zero, maybe due to some bug or you've been debanked or whatever. zkTLS can't help you there. It can't somehow introspect into the server, the bank server, and like determine whether you actually spent the money or whether this is a bug or you've been debanked, right? It can't do that. All it can do is see that the official source is saying that you have zero, so it will generate a proof about that if you want, right? And similarly, maybe the bank one day is misreporting your balance as double what it should be. In that case, zkTLS, it sees that the official source is saying you have double what you think you have, and so it will generate a proof if you want. It can't discern the truth of the matter, right? So the trust lies in these servers acting honestly, and there's another point of trust actually. So we need to be sure that we're connecting to the right server. So zkTLS can prove that this server is saying X, it's saying whatever it's saying, but we want to be sure that this server is actually the server, official server belonging to some service, our actual bank or Uber or Airbnb. So for that, we lean on these certificate authorities. And I'll explain this more in a second. This is just kind of how the internet works. We rely and place some trust in these certificate authorities to put us in connection to the official server for some official service. So again, zkTLS sits on top of this system, and there's these two primary points of trust that we kind of just have to accept. And zkTLS can just generate a proof on top of that. So how does zkTLS actually work? To understand that, we need to understand TLS, because zkTLS is basically an extension of TLS. And TLS is transport layer security. This is a protocol for establishing secure communication between client and server across the internet. So whether it's your laptop or smartphone connecting to Facebook, Amazon, Instagram, or your online banking, whatever, TLS will be used to establish that connection. And more specifically, TLS accomplishes three things. First is privacy of communication. So all data being sent in both directions should be encrypted. Two is integrity of communication. So we want to make sure that anything we send can't be intercepted and changed by some third party, right? And three is authenticity. We want to make sure the server we're communicating with is the official server for our bank. I'll go over the steps TLS does to accomplish that. And for completeness, I'll include a step that happens just before, which is the DNS step. So in the beginning, you go to your browser, you type facebook.com, and your browser, your computer, needs an actual IP address, the address for an actual server to communicate with. So we need to map that domain name, facebook.com, to a server address. And that is the job of DNS, the domain name system. It'll do that mapping. So then the client has an address. So it will establish a connection to an actual server. The server will reply with a certificate. This certificate is a bunch of data. And in that data, among other things, is an attestation saying, yes, this machine, this server belongs to this organization. And we will then take that certificate and verify the signature on it, because hopefully that certificate is signed by a certificate authority. And these are trusted entities, authorities, which take on this role of vetting these servers and making sure that they do belong to a certain organization. And if it all looks good, they will sign this certificate. So we place some trust in the certificate authority to do its job properly. But then as the client, all we have to do is check the signature on the certificate. Looks good, belongs to a known CA, and we can proceed from there. So then the client and server will create symmetric keys. So they will generate together shared, essentially private keys that they can then use to communicate with. And just as a note, there's other ways of establishing private communication between two entities on the internet, but creating symmetric keys in this way is very efficient. It's very fast. So the client can create some data, encrypt it with its key, send it to the server, and the server can decrypt it because it has the same key, and it can do that very efficiently. So now they can communicate securely. So at this point, this setup works really good for regular internet use. But the problem here in the context of zkTLS is, given just this stuff, we can't prove to the world some data that was sent, right? If I'm the client and the server has sent me my bank, profile page, and you can see I have $37,000 in my checking account, I can't take that data, that payload of data they sent me that contains that information. I can't just take that and show it to someone and be like, look, here's proof. Because the server does not sign that data. Remember, we have shared keys. The data being sent is not digitally signed. The certificate is, but that's different. The actual data is not signed. It's just encrypted with a key. But the thing is, we share the key. So what I could do is, server sends me some data with this profile page. I could decrypt that and change it, add a 0 to my bank account balance, and then re-encrypt it or whatever, just show it to someone. But you wouldn't be able to tell that I had modified the data. So zkTLS needs to solve that problem. And I won't go into a ton of, or really any detail about how they do that, because it's a huge topic for another video. But we have systems like opacity and reclaim, which take on this task. You as the client request your accounts page from your bank, and it returns this data. Now we need to generate a proof that takes and says, this value for your balance in your bank account, that data, we need to link that back to the server, right? Back to this official server. and back all the way to the certificate that came from the CA, the certificate authority. At a high level, that's what zkTLS does. So now we'll look at some of the actual use cases for zkTLS. The first use case I want to point to is a really big one, and this is in DeFi. This is uncollateralized lending. Two major functions of the modern financial system are medium of exchange, having like a money, right? And in the DeFi realm, we have stable coins, so that pillar is essentially solved. And then also the expansion of credit, the creation of credit. And this is really important. And in DeFi, we have some of this, but not nearly the range of credit kind of vehicles that we have in traditional finance. So most DeFi lending is over collateralized, right? You lock up maybe like $150,000 worth of ETH, and then you can draw 100,000 in USDC out. And that's great, but typically, if you want to borrow money, you don't have the money, or that's very often the case, right? You go to buy a home or take out a line of credit, it's because you don't have the cash, so you want to borrow some, right? So what we want to eventually reach in DeFi is not just this over collateralized lending, but also collateralized lending. So mortgages, car loans, this is a huge sector in finance. And there you have a piece of collateral, right? There's the car or the house, which can be repossessed if you don't pay your loan. So there's that. But then also uncollateralized lending. And that's credit cards, lines of credit, something where there's not some collateral that can be taken by the bank or whoever, right? But in order to accomplish that, you need credit scores, you need a reputation, you need some link to an identity. And, in the traditional financial world, there's this whole system for doing that. There's credit scores and there's financial history and all these things. And so that's how that works, right? Now, in order to bring this into the DeFi realm and have uncollateralized loans, it would be helpful to bring some of that into DeFi. So that's where a system like 3Jane comes in, because this is what they do. They bring this real world credit score and financial assets and these records that have been kept over many years, and they allow that to be imported into a crypto DeFi system so that you can then have loans offered to people, just like in TradFi. So this is a pretty compelling, pretty interesting use case. And as I alluded to, the size of this market is absolutely huge. So of all of the lending in the world, there's like 150 trillion global and 20 billion in DeFi. So TradFi is 7,500 times bigger. So that's kind of the total TAM that we could eventually reach potentially. And then of that, if you look at uncollateralized lending, it's 6 to 7 trillion. And in DeFi, it's like 1 billion. So in DeFi, it's very small right now. And so this could go 6 to 7,000 times bigger if DeFi consumes this uncollateralized lending use case. So that's one. Something I neglected to mention earlier is that zkTLS is not just about bringing information from the outside world into Ethereum. That is a powerful use case for it, but it can also be used to prove something about the normal world, like your bank balance or whatever, to another system in that regular world. So it doesn't have to have anything to do with crypto at all. And an example of that is Earnify. This is a payday lending system. And Earnify has nothing really to do with crypto at all. It's just a real world system that has traction. It was number 2 or 3 in the App Store in the finance category. And what it does is supply payday loans. So as a borrower, you will present, your employment documentation, some proof that you have some income on the way, and you present that to the lender and then they give you some money. Where zkTLS is used with Earnify is that rather than having to present these documents and have them manually reviewed or something like that, you can present a proof. You can have a ZK proof proving that you have a certain amount of money hitting your bank account in a certain amount of time. And then the lender can be super confident that the money is in fact on the way. and they can issue the loan. And the advantage here is that if you present a proof as opposed to some documents that have to be manually reviewed, that is a much less error-prone process. This should reduce the fraud that happens, and therefore the payday lenders should be able to offer a more competitive rate. And, as I'm sure you know, payday lending is quite predatory at present. The rates are very, very high. And so if fraud can be reduced, these rates can be lowered, and it can be made more fair. So that's one sort of real world use case that, again, it doesn't touch crypto at all. It doesn't touch crypto at all. It has nothing to do with Ethereum, right? The zkTLS system is just used to provide this proof. And the only role that Ethereum or crypto plays here is that, for a system like Opacity or Reclaim, they may have some integration into Ethereum or into a crypto system to provide, for example, crypto economic incentives such that these proofs are generated properly and we have confidence about them, right? Which I may explain in another video. But so it's using crypto, it's kind of running in crypto, but it's being used by stuff that is not related to crypto at all. And that's good. That's a real use case, right? So another one is invoice factoring. Invoice factoring is a huge market worth trillions of dollars. And it's actually a lot like payday lending, but for businesses. So the way it works is that suppose you're a shipping company. You've shipped a bunch of products for Coca-Cola. They have an invoice that they're going to pay to you for a bunch of money, like 45 grand, but it's due in like 60 days. So it's going to be a while. In the meantime, you have to make payroll. So you have this invoice, which will almost certainly be paid, right? Coca-Cola is not going to default on this debt. And so that money is almost as good as cash, but it's not liquid. You can't do anything with it. It's frozen there, right? So you would like to get a loan against that money. So you go to some financial institution, and presently the way this works is that they will actually often just like ask for your login credentials. This is what I've been told. They will take your login credentials and like log into your, invoicing system through Coca-Cola or whatever, and manually check that you have the invoice on the way, right? And then they'll see it's come in and they'll give you the loan. So with zkTLS, we can just present a proof. We can just prove to them that the invoice is on the way. It's for this amount of money. It's coming from this reputable company. Boom. So you don't have to share these credentials. It's not this clunky manual process. It's like a mundane almost use case that you wouldn't think of. It's not like, I've never heard of invoice factoring till I started researching for this video. But some of these mundane things are massive. This is trillions of dollars, this market. And if zkTLS can make this process more efficient, less prone to fraud, etc., that can actually be a giant real world use case, a real world win worth who knows how much money. Another one is mixed markets, stuff like zk P2P. This is a way you can have a peer-to-peer on-ramp, off-ramp to crypto, which I hadn't thought would be possible, but the way it works is this. So party A sends, let's say, 1 ETH to a smart contract. Now, party B, the one who wants to buy 1 ETH, who wants to on-ramp to crypto from USD or whatever, party B will send the value of that ETH to party A via a TradFi system like Venmo or whatever. So then B will provide a proof that they've done this, a proof that they've paid to the smart contract. And then the smart contract will release that ETH to party B. This works because no party here was ever taking any real risk in a sense, right? So A sent the ETH to the smart contract, and if B never paid, that ETH would be sent back. They would get their money back. Party B, they sent the cash while the ETH was in the contract, but as long as they provide a valid proof, which obviously they're going to, they'll get the ETH. So, and there's nothing that A can do to stop that happening or anything like that. The whole thing is trustless, and it allows for this peer-to-peer on-ramp, off-ramp. And again, what's really interesting here is that it's peer-to-peer. It doesn't require some centralized exchange. It's just people, it's creating this kind of mixed market where you have this real-world payment system sort of integrating into a smart contract Ethereum-based system. Because again, now with zkTLS, the smart contract can see the outside world. They can see you made a payment via Venmo, thanks to these proofs. So another whole category of use case is in social media. And there's some really interesting stuff you can do here with zkTLS. For example, the founder of Dig, Kevin Rose, tweeted recently that he's working on Dig 2. And in Dig 2, they're going to integrate zkTLS so that commenters can make claims which are verified. For example, there might be a review thread going on for the new Aura ring, and owners of that product could, give their opinion in such a way that it's verified that they actually own it. And I think there's many more ways this could be used, but that was the example that Kevin gave in his thread. And so I've drawn up a couple more examples of things that I thought of. So you could have a user profile where on this new social media site where you can prove that you have a certain number of followers on X, subscribers on YouTube, maybe a certain GitHub contribution history. That could all be proved and verified in your profile. Another idea would be you could have an investing platform, and maybe this wouldn't be the best idea, but it would technically be possible. You could have an investing platform where users could prove that they own a certain amount of stock, or that they bought at a certain time, or that they made certain calls, like they actually purchased certain stocks at certain times and have a certain performance over time. They could prove their net worth. They could do all of this anonymously, but still in such a way that there's a proof that they have a certain net worth. There's a pretty wide design space of what can be done with zkTLS in terms of social media. zkTLS can also be used in marketing. So this is something I'd never heard of, but there's a system called Daisy, which addresses this sort of problem in social media marketing. So apparently the way this typically works is that, say like a bunch of influencers will, one of them posts something, and then a bunch of those other influencers will coordinate to pump that piece of content, right? They'll engage with it, they'll like it, whatever. And, for better or worse, this is what happens. But the way that works now is basically just kind of an honor system. They share a little bit of the revenue or whatever, but there's just an honor system or like a mentally keeping tabs on who contributed to what. So it's all done manually. But with zkTLS, you can have proofs that you engaged with some content. So you can have this swarm of influencers engage with some content or take some action in a social media platform, and then provide a proof. And then you can have them programmatically paid out. So you can have this kind of coordination mechanism for these swarms of influencers. So, and by the way, there's many more. There are decentralized ride sharing networks being developed, which is partly why I included Uber in this example here, where you can, for example, import your driver rating from Uber to this new decentralized system. And therefore you don't have this cold start problem where you're trying to, start from scratch with no rating, no history. You can bring your reputation over that you worked years to build into this new system. And that makes the new system that much more compelling and more able to get off the ground. So there's much more that zkTLS can do, but I hope these examples give you a sense for the potential here. And I think the main point to remember is that, again, we have this big ocean of data, these centralized services which have been managing our lives for many, many years. And this is our world. This is what runs our world in some sense. And, Ethereum has this limited vision to this world. And with oracles, we can bring in just a bit of that data, just the public stuff, the asset prices and so on. With zkTLS, we can open the floodgate and bring in like a ton of this data, and we can start to rebuild our civilization, perhaps. And not only that, not only can we bring information into the world computer, but we can also have the world computer act upon and respond to actions taken in this wider world. Because again, we can prove an action was taken, not just bringing information in. So what this does is it's expanding the vision and like the influence and capabilities of the world computer. And it's bringing it closer to this ultimate vision, which to me is this place where we can program our civilization, where we can engage in civilizational programming, building institutions and systems, all manner of institutions in this place with code, with different systems, a next generation of systems. And then in addition to that, we have these use cases which have, which are kind of completely outside of crypto. We have these applications of zkTLS, which are used for communication between two centralized systems, for example. So this is just a big win in terms of real use cases coming out of crypto. But again, to me, the real big vision here is that we're getting closer to this world computer, which we can start to engage in civilizational programming, where, building the civilization of the future becomes almost like this giant, like Minecraft-esque collaborative project. And that to me is pretty exciting. Thanks for watching. Next videos will be on espresso. I have more eigenlayer topics. I might do a Caspa video at some point because I've had a lot of requests for that, and many more. Maybe something on the Elohim, etc. So watch out for those. And yeah, thanks for watching and see you next time. Peace.